I will make a skeleton for you in this chapter. This is the easiest way to brief the chapter for the medical and engineering examination. As we know that wave is propagating through a particular equation, y is equal to a sin omega t plus kx or kx minus omega t. In this particular situation, from a point A to a point B, on the basis of the energy propagation or how much energy is transferring from point A to point B, maybe by the method of compression or maybe by the method of elongation or rarefication and compressions, that decide by the energy variations between 2 points. If we see the energy from the point A is reaching to point B without losing between any trough and any crest, definitely the wave is stationary in nature. Stationary wave doesn't mean wave is stationary, wave is stationed in some station. It's not like that. Stationary wave implies energy is not losing between 2 points of propagation. Implies if I say hello to you through my mobile, definitely the whole intensity is coming towards you as I am saying. Maybe you are 200 kilometers away from me. But if you say it even 20 kilometers away from me, and in open air I say you hello, definitely when the hello will come towards you, it will be more diminished in their intensities. Maybe I am speaking here loudly, but when you listen the word, that energy intensity is decreasing. See, if the energy intensity is decreasing in the trough and crest between two propagations, we consider wave as a progressive wave. So on the basis of the energy variation from one to other point, waves are two types. One is progressive and second is stationary. Now, on the basis of the character in this situation under propagation, if a particular wave is propagating through a medium or without any medium, but directional propagation of the velocity of the waves is perpendicular to the pressure developments by the waves itself. That is maybe mechanical pressure, maybe electromagnetic pressure. The pressure variation on the waves is perpendicular to the direction of propagation. If one is moving towards the z negative, so maybe velocity and negative z axis, but pressure is coming to positive x axis, like that. So in such a situation, when the pressure variation is taking place perpendicular to the direction variations of the velocity, then we consider the wave is transverse. If the medium is present, for the sound wave chapter, we can say if the particle present in the medium, such as if you take, this is a point where all particles here present as a medium and a sound wave is traveling towards it, and the particle of the medium is vibrating in this way, but wave is vibrating to that way. Then the pressure exerted on the particle is along y-axis, whereas the velocity of the waves is along x-axis, then you consider the wave is transverse. But for the non-mechanical waves, such as someone can ask you in IIT or normal medical examinations, why light wave is transverse? Although it can be transferred through without presence of any medium. So that's why proper definition have to know. And definition is that if the pressure variation takes place due to the propagation of the waves perpendicular to the direction of propagating velocity, wave is considered as a transverse waves. In the electromagnetic wave, you will see the velocity of the light is perpendicular to the electrical field pressure, that is half epsilon naught E square, and perpendicular to the magnetic field pressure, B square by 2 mu naught. That's why light is a transverse wave. But if you see that in the same medium, in the presence of the medium, in the same medium, when the wave is trying to propagate through it, and due to compression and acidifications, the particle of a medium getting the same directional pressure as the velocity of the wave is there, then this wave is considered as longitudinal waves. So longitudinal waves and transverse waves are on the basis of direction propagation between the velocities and pressure developments. And for the energy variation, you already know they are progressive and stationary.